All right, so good evening, everyone. Our priority for our class is to set up a custom VPC. So I was thinking, yeah, I told people that um for the next task, you create a server and deploy your dream vacation app on that server. But you do use the default settings. But I had a change of thought. I'm like, why can't you just deploy everything at once? Build the whole networking from scratch. Probably now I'm going to teach that to you in this class. So yeah. Um we'll look into that for the purpose of this class. So let's get it. Please confirm you can see my screen.
Yeah, I
Can
can see it.
anyone? Okay, so first thing we're going to do now, we're going to create a VPC. We're going to create a VPC. So create a VPC and we'll name it, let's just say KodeCamp Prep 6. This is our name of our VPC. Now, when creating, okay, let me even start from the beginning. Let me don't rush to create VPC. Let me explain what fundamental concepts for you. Let us talk about regions, availability zones, and then CIDR blocks. So, um, now as a cloud engineer, you hear a lot of things called regions. Oh, region. Let us put it in this region. Let's put that in this region. So what is a region? Yeah, a region is a geographical area where a cloud provider like AWS has data centers. So data centers are the centers that are actually storing these resources, these infrastructure that you are currently trying to rent. For example, if you want to rent a server, which is an EC2 instance, the rack of servers where you are going to just only pick one to rent is called a data center. And these data centers now, um they have multiple different servers depending on their size. So you are now going to like rent the one that you want to use. You understand? These data centers are isolated from others to ensure fault tolerance. So data centers are spread across different regions, different. So a region is just like just like having one data center now in just like having one data center now in River State, then having another one in Lagos, then having another one. So that River State now cover like south. You understand? Lagos want to cover southwest. Then you have another one in Enugu that covers southeast and the rest. That's what regions are. Then within the region, there are availability zones. Availability zone is like also another segregation within the region. So if I have a data center I can have a data center in um River State now. This data center in River State will now be further spread into, let's say, if you for those that are familiar with River State, let's say Chuba and Romokoro. These are the data centers. That's how it is spread. So if I'm deploying an application in one data center in Chuba, I now, you can deploy the same application in Romokoro just to ensure that if anything happens to the one in Chuba, you can still access it in the one in Romokoro. That's what they call high availability. I'm sure if for those that don't know these areas, I don't know what else to use. Probably in Lagos, you can have one. But one thing about data centers is that they should not be too far away from each other and they should not be too close to each other. So that's one thing, availability zones rather. So yeah, that's what they are basically. So a region can have between 2 to 6 availability zones. The default region that you always have on AWS is the North Virginia region, which is what we have here. Once you open an account by default, you have the North Virginia region, and the North Virginia region is the region that has the most availability zones. And the availability zones are grouped in like with letters. So you have um US East 1. So US East 1 now is the North Virginia region. You get, so this is a region now around North Virginia. Within this region now, there are 6 availability zones. There's US is 1A, B, C, D, E, F. You get, this is the one that has the highest. Some of them have 4, some of them have 3, some of them have 2, depending on the state. The reason why this is the default is because it's the first region that ever came out. This was the first region that ever came out when AWS started in 2006. So AWS is the oldest cloud provider, started in 2006. And it started in North Virginia region. Well, until they got North Virginia, they decided to export, to expand to other regions, other parts of the world, for other people to be able to access cloud services. So, yeah. So when we're deploying an application, we're deploying an application in an availability zone, in a region in an availability zone, and we're going to use North Virginia. We're going to use US East 1A in North Virginia, which is the availability zone inside that North Virginia region. One thing that availability zones and regions help us to do is latency. And what is latency? Latency is the ability for the internet to reach your application and come back. So for example, if I ping www.xyz.com as I'm in Lagos, if my application is in Los Angeles, if my server rather is in Los Angeles, it will take a bit of a while to do that whole travel. When you ping your internet to travel, come back. That's what latency. So the time taken for it to travel to give you a request and response is latency. Then, so it's always best to prevent latency issues. It's always best to um it's always best to build your applications around your potential customers. You understand? So if you know your application is going to have customers in the US and these customers are located in Los Angeles, where is the closest place to Los Angeles? North California. You get, is the closest. But you can still use North Virginia though, but sometimes um you just need sometimes you can even with compliance purposes. Now, for example, there are some data protection laws. There's some data protection laws. Let me Google some of them. GDPR. Yeah. There's some data protection laws like in Europe, you know, where you'll be required, you won't have to you have to, protect your data. So if you're building, for example, now you're building an application in Europe, like the application, the users will most likely be Europe. You have to obey what they call GDPR laws, which ensures that data should not leave the data or the people that you are building for should not leave the European region. You understand? It has to be within the European region. So if you're building an app that you know that, oh, the people in Europe, probably in the UK, will use, it do not make sense to go and put your servers on US East 1. You can be arrested for it because it violates compliance, GDPR compliance rules. So yeah, that's just basically it as well. You get there are a lot of them. I won't really talk about compliance in this class because out of scope, but that's just what it is. So I've explained what regions are, explained what availability zones are. You can go and do deep research. Now we're talking about CIDRs. CIDRs simply mean classless interdomain routing. It helps to define the IP range where you can, where your networks will be. Like this goes back to networking. So when you're building your network, you have to define the IP range where your network will dwell, that will be attached to your resources, or the resources that you're currently creating. You understand? So for this our class, um we're going to use this. So let's do this. 10.0.0.0/16. Now, what does this mean? I don't just want to start writing sliders. What does this mean? This means that any IP range from 10.0.0.0 to 10.0.255.255.255. I think I'll have to write that down. Um, let me write that down in the comments. 10.0.0.0 to 10.0.255.255. This simply means these are now, if you calculate all these IP addresses now, they are equivalent of 65,536 IP addresses. Write it in the comments so you all can see the comments. You can, if you want to view it. So these have 65,536 IP addresses. You understand? So this simply means that any resource that any resource that you're creating, you can create as much resources within this network, up to 65,536. You understand? If a resource that are created within this network has an IP address, you understand? Each of the resources is like just like one, you understand? Just like one, basically. So each of them have 65,536. That's the amount that you can create within this network. So that's what it means. Now we can go down to subnet. Now let's just keep creating. Now we have defined this, which is 10,000, 10.0.0.0/16. We'll now do a tenancy default. We'll leave this one at that. Then we'll do a target. So when we do the target, we'll do create VPC. So I've created the VPC. Yeah. So now I've created this. Next thing I'm going to do is to create subnet. Now, there are public subnet and there are private subnet. For the purpose of this class and for your assignment, you're going to create only public subnets. When we are doing the next cloud task, the next cloud task, we're not doing DevOps, which is the whole deployment. We're doing purely cloud because the cloud and the DevOps class. We're going to build stuff from scratch, basically with DevOps, with cloud rather. I'm talking rubbish. Then there is the create now do create subnet. Now this name of this subnet, we can select the VPC we created. Be careful so you not choose the default. This default comes with every region. Please ensure that you don't delete it. A default VPC comes with every region. That's the default VPC we used to. Can you hear me? Please confirm you can hear me. Hello.
Yes, I can hear you.
Okay, my screen went black for a bit. Okay. Now, each region comes with its own default VPC, and that's the default VPC that we used when we were building that EC2 and the rest of all the things we did in the last class. But I'm showing you how to build your own because some companies want to implement security measures, so they don't want the default. You understand? So now this is mine, KodeCamp practice. I click on it. Now, what is subnetting basically? Subnetting is simply breaking down your subnet into parts. Just like the VPC is like a cake. Let's just attribute the VPC to a whole piece of cake. You understand? You don't eat a whole piece of cake. You get me? To be greedy, you'll be a greedy person if you decide to carry a whole piece of round cake and put in your mouth. So what do? You divide your cake into parts, probably little triangles that you can easily share, take one portion for yourself and eat. So that's what subnetting basically is. So subnetting means dividing your infrastructure networking into different parts that can be ideal to handle the resource that you're working on. So now what we need to do is to deploy an application into a public subnet. You understand? We don't want to go and we don't want to over over create. So we have to segment the infrastructure to handle the resource that we're going to deploy. The name of subnet is public subnet. Then we're using US is 1A, which is now you can see if I scroll down, you see all the resources, you see all the availability zones. US is 1A, B, C, D, E, F. Depends on the one you want to do. So we're doing A. And you see the IP address of the this is the IP address of the VPC. Now we have to create it. Now, creating means how do we create it now? We'll do 10.0.1.0.24. So this 24 now it is smaller. This 24 now it's like a cider notation that indicates that this is a subset of this. So this now will contain 256 IP address, which is out of the 65,000 that is here. We're chunking out 256 IPs that will be used to house our public resource. So that's what it is. So if you're creating multiple of them, you have to do the 2, 3, you have to like tag them appropriately, 256 like that. This simply means that if you want to create up to 65,000, you just chunk it like that, but it doesn't make sense to start, depending on what you want to do though, but this is my preferred option. So if I do create subnet now, I create this subnet. Now, in as much as we labeled it a public subnet, what is a public subnet? A public subnet is a subnet that houses resources that needs to access the that needs internet access, basically. So a public subnet houses resources that needs internet access. If you don't want your resource to be accessed from the internet, then you should not create a public subnet. You should create a private subnet, which we will do in the next class. The reason why I'm creating this one is because, I don't want to show you the basic networking. For the next week, we're going to build a full infrastructure from scratch, where you have a public subnet, you have a private subnet. Now you're going to put a resource in a private subnet. You understand? You have to put a resource in a private subnet and a database as well in the private subnet, because databases should not be accessed from the internet. So you have to put them in private subnet. So yeah, but this is a public subnet. Public subnets are used for resources that should access the internet. Or rather, I'm always mistaking this thing. It should have, like, people from the internet should be able to access the resource, not the resource should access the internet. So yeah. So if I want a resource now that, I need someone, people should access this resource, that's when I use public subnet. Now, me naming a public subnet doesn't make it a public subnet. We have to go some extra configurations to actually make it a public subnet. So what are we going to do? We're going to create internet gateway. So the internet gateway is what is the work of the internet gateway? The work of the internet gateway is just like the name implies, an internet gateway. It is what leads the internet into your resource. So without the attachment of an internet gateway, your resource will not have access to the internet. So we have to create an internet gateway. It is often referred to as the main door between your VPC and the outside world. If I do KodeCamp IGW, which is internet gateway, I create the internet gateway. Now, once the internet gateway is created, you could see detached. The state is detached because we have not attached it to the VPC that I want to connect it to. So we'll click on actions, attach to VPC. So when I attach the VPC, you attach to the VPC that you created, which is attach internet gateway. So now I've attached the internet gateway to our VPC. Now we'll go to route tables. Now what do we do? The route table is like the traffic controller. You understand? The route table is like the traffic controller that tells your subnet, oh, this is where you should go. So this thing here, oh, you're seeing public subnet here. The fact that you're seeing public subnet, the public subnet does not mean anything. It is just a normal subnet. It's attachment and routing through an internet gateway that makes it a public subnet. Now, next thing we're going to do is route table. So we're going to go to route table. We're going to create a route table. Route tables, like I said, a set of rules that control where network traffic should be directed to. It's like a GPS. So take it as a GPS or like a traffic controller. We do public route table, or let's just say public route table. We select our VPC, which is this. Then you create a route. So once you create a route now, you go to, now you see routes here. Once you see routes, you go to edit routes. When you go to edit routes, you go to, please, if I'm too fast, let me know. I can go back. You go to, now you select this 0.0.0.0, meaning that anyone in the internet. This is what it means. Whenever you see this cider block 0.0.0.0, it simply means your resource should be open to anyone in the internet. That's what it means. You understand? So for the purpose of this class, we're enabling our route table. We're opening a route table so that the application that we deploy to the public subnet, anyone in the internet can access it. This is yeah. So that means if you go on your phone now and click on the IP address of the server, you can open it. You can use on any device. It's not restricted. Now, so select target internet gateway. The internet gateway that we created, KC gateway. So we save changes. Now that we have saved changes now, we have indicated that this route should be connected to the internet gateway. You understand? So that means this route now officially a public route. You understand? Now we'll now have to attach our subnet to that public route. You can see explicit subnet association 0. Subnet without explicit associations 1. So we edit subnet associations. When we click on it, you see save. You can see save. When you see save, you can see that our attached our public subnet to this route. That means anything you deploy to this public subnet will have access to the internet. So now that I've done this, so this is just basically it. So now let me show you how to create private subnets for situations where you'll be required, oh, create a public subnet and create a private subnet. Let's go, we'll create a private subnet, create a subnet, private, oh, create subnet, put the name private, private, same available. Same now. This one now, since it's a different subnet, we label it to /24. Then you click on create subnets. So now I click on create subnet. Next thing now is you have to create an elastic IP because um being in a public subnet, being in a private subnet, you don't have access from the internet. If your resource is a public subnet, you don't have access from the internet. However, you need that resource to be able to get updates from the internet. So internet gateway allows traffic to come from the internet to your application. Now we have what they call a NAT gateway. A NAT gateway is what allows traffic to come from your application to the internet. That's what a NAT gateway does. So if you have an application in a private subnet, the application should not be able to reach the application should not be able to reach the internet. Sorry, the application people on the internet should not be able to reach it. However, the application itself will need to reach to the internet for updates. If you want to perform updates, if you want to do some, all those pseudo apt update and the rest, you need the internet. Now, you need an elastic IP address because elastic IP address is what will be attached. It's an IP address. It's a static IP address that should be attached to the NAT gateway. Once it's attached to the NAT gateway, you understand, it now enables the NAT gateway to be accessed, to access stuff on the internet. Let me do it first if I explain. This one is the one I created earlier. So I've already created this. I don't need to create. You can just click on allocate. But this one I created earlier. I didn't forget to delete it. So this is now call it now. Now go to NAT gateway. When we go to NAT gateways, you see no NAT gateway found. You create NAT gateway. Now let's do CK. This particular one is not necessary for this your task, but I'm just showing you. I'll say emphasize it on our future, like the one we're going to do next. Subnet. Now this subnet, now you have to put the NAT gateway in a public. You have to put the NAT gateway in a public subnet because it is now, like I said, resources on the public subnet is resources on the public subnet can allow access from the internet. So the NAT gateway being in the public subnet, it will allow access from the internet to the NAT gateway, but so it is the NAT gateway that will bring all those updates for you. Then to now pass it down to the resources in the private subnet. I don't know if you understand that. So remember when, let me use this analogy. You know me, I'm always like to, we break things down to everyday analogy. Remember when, yeah, if most of you that went to boarding school, yeah, you may have been in boarding school. What is a boarding school? In boarding schools, you won't be able to go outside to go home. You understand? You won't be able to go home. You won't be able to leave the boarding school. But there will always be a man, like a gate man or like a housekeeper or something, where you will be giving money to say, take, help me buy socks in the market when you go outside. You understand? Because that man has access to go outside and come in to see you. But the people, probably your parents or something, cannot come and see you. And you in the boarding school cannot go outside to see your parents. Or rather, the people in the market cannot come to you in the boarding school. And you in the boarding school cannot go to the market. So you will send your gate man, oh, take this 500 and help me buy socks. So the gate man will go to the market for you, buy socks, and bring it to you in the hostel. See, that gate man is what we call the NAT gateway. See, this analogy I just gave you now is what the NAT gateway does. So the resources are locked in. The resources are locked in the, why the clap? The resources are locked in the private subnet. People in the internet cannot reach it. You understand? So it says the NAT gateway is there so that it can get details and it can get updates from the internet for it to function properly. So we have to put that NAT gateway in a public subnet because the public subnet is what has access to the internet. Do you understand? Please unmute yourself and tell me you understand after this analogy.
So I have a question.
Okay.
Yeah. You said the reason why we are creating the private subnet is this NAT gateway there, right?
Yeah.
Yeah, but you are the one that is saying that we have to put it in the public subnet.
We are putting the NAT gateway in the public subnet, not the resources in the public subnet.
Okay. All right. I thought you were saying we are creating the private subnet.
No, we're creating a private subnet for hosting our resources. But the private subnet is connected to a NAT gateway that will be in the public subnet. Do you understand?
Yeah, understood now. Yeah.
Good. So just like I mentioned now, like I mentioned about the school analogy, the resources are the students in the hostel. The hostel is the private subnet. The NAT gateway is the gate man that's standing at the gate. You understand that you give money to go and buy something for you, but you cannot leave the gate. Do you understand?
Yeah, I understand now.
Good. Then your parents as well cannot come and see you because it's probably not visiting day. That's the whole analogy. Now we have, since it's in the private subnet, we have to give it an IP address because an IP address that will go and be fetched. So it is the IP address assigned to the NAT gateway that will be going to do all those fetching for you from resources from the internet. So we have to assign an elastic IP to it. So we create a NAT gateway somewhere on the clap. I do my best to explain these things in the most simple terms because if I talk bogus cloud English, it will fly over your heads. You understand? That's why I'm always trying my best to explain it in the most everyday scenario. You understand? So now NAT gateway is pen. This NAT gateway, you're not going to use it for this. So you're going to create what your for your task, you're going to create public subnet that you use. But I'm just showing you how to create a NAT gateway. Now this is going to take a while. It's pending. You keep refreshing, you keep refreshing, you keep refreshing. It's going to take a while. Just be patient. Next 3 to 5 minutes. So yeah, so that's just what it is. And please, when you deploy all these things, once you take your screenshots, please delete all the resources. I'm even surprised I still left my Elastic IP because that one is a money guzzler. Delete everything you created. Once you have proven that it works, take your screenshot, done in documentation, delete all resources because AWS charges per hour, like I mentioned in the last class. So for every hour you leave a resource going, it accumulates, 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 accumulates. Once it accumulates, bam, your money is ready. At the end of the month now, to send you bill, says Mr. Ezekiel, I told you to create a AWS account. So yeah. And you should also be careful because most of these networking resources don't have free tier. So if you have a free tier account, you have to be careful. And I can see it's available. So once it's available, now you go over to your route table. You go over to your route table, you click on create route table. So once you create route table, you see private RT, private route table. You select the VPC that we did, and then you create. Now you create the route, you now see edit routes. Address. So the last time we did 0000 to internet gateway, but this time we're doing 0000 to what? NAT, to NAT gateway, to NAT gateway. So now we're doing that. So that means the this is now what makes it a private subnet because it's connected to the NAT gateway. So that means if it's connected to the NAT gateway, any resource that you put inside here, nobody will be able to access it. Then you click on subnet associations. You now attach the subnet, which is the private subnet that we created to it. Private subnet that we created to it. Now, this is what makes the public and private subnet. Now, we go over to our EC2. You're going to document, like I said, you're not going to use private subnet for your next task. You would use public subnets. Then you create an instance. Click on launch instance. Click on name. Let's just say KC. You have name. So people must have been aware of all these ones. You are aware of all these confirm changes. You should not just waste my time now. Now we are doing T3 micro. doing doing when you go to edit, you can see default VPC. You change it to KC crack. You change it now. You can see showing public subnet. You click on enable auto assign public IP enable. Create a security group. I already have a security group, so I'll just select it. Practice. Already. Do I need to create another one? I'll just create another one. So your new security group content is practice. Security group already has SSH, so you just give it HTTP. HTTP is the internet protocol to enable it to be accessed from the internet. Source 0000, which anybody can access it. It's ideal now because it's in the internet. You need everybody to access it, basically. So advanced network configurations. This is the storage. This is the storage. Then uh, yeah, this is storage. Then advanced details. So these advanced details now. You can write a script here. You can see this place they call user data. This user data area now, you can write a script that you want to automatically be triggered or you want to automatically be run when the server comes on. You can write the script here. When we're doing our next cloud task, we're going to do this. We're going to use this basically. Then you click on launch instance. Okay, now I've launched our instance. We go to okay, coming up. I can see KCEC2. It's running our this thing. So we'll just allow it to just load properly. So you click on connect. When you click on connect, you copy this connection, this thing, go to your terminal. For those of you that are using Linux, you go to your terminal. For those of you that are using Windows, you go to your git bash. And before using git bash, then the rest. CD download. So download is where my public key is. So that's why I want to go there. Uh-oh. I just realized that people are not seeing my hold on. People can see my git bash, I guess. So you go to git bash and then you copy you paste the connection string, which is this. So yep, you can see that we can connect. Voila, we are connected. So this simple project we have done shows a custom VPC created to launch an EC2 instance. So the next step is your own. Oh. After you have launched this instance, go to uh, go to your GitHub Dream Vacation app. Let's save this guys. Yep. Yep, yep. Sorry, Wilfred, I'm opening your this thing in class. Well, that's the advantage of being a good student. We then will use your this thing as marking scheme. So yeah, you can see this part where you have build and push image. Now I want you put again to create a new branch. But this I don't want anybody to tamper with this branch. So create a new branch for deployment. You will redo this one again. I want you to do it step by step. This new branch, usually when I want to create a new branch, so you won't tamper with the tax branch because what you have submitted. Most of you, we're going to tamper with your main branch that I told people not to touch. So I'm not going to say anything. This one, the next one. Uh, so now this is just you do the exact same thing you did here. Oh my God, you do the exact same thing you did here. The only difference is that after you have done this build and push, you now do another. This is build, basically. You do another job, which is deploy. So this build now is the build and push. You do another one, deploy. So I'm giving you expo. After this build, you do deploy. Now this deploy will need no. First of all, after you have built this, write another step. Write another step that comes to paste the GitHub SHA. This GitHub SHA now that was generated, it comes to paste it here. Come and paste it. This Docker Compose. Where is the Docker Compose? To come and paste it here. Should come and paste it here. So for every time a new build occurs, it should come and paste the GitHub SHA here. Meaning that it is going to paste. So because it's the GitHub SHA that is registered on the Docker Hub, so it come and paste it here. So after you have this with 2028 at dream backend slash the GitHub SHA. So for every time you build that new GitHub commit ID, which is the SHA, you come and replace it in this place as the where you normally have latest, the version. Come and replace it here. So that's what will complete this. That is what will complete this build pipeline. So after this one, after build and push, you can name update Docker Compose YAML with kini. You write all the. I think they use I think you use. I can't remember the command, but you figure it out. Then you build another job again. You understand? This new job will now SSH. So you copy your key pair into secrets. You go to secrets, copy your key pair and paste it. Now, this new job now will SSH into this server that you created because it's a public server, accessible for anywhere in the internet, including with GitHub Actions. SSH into it. Copy this Docker Compose. If you copy this Docker Compose or copy this entire file into the server using what they call rsync. The command is rsync. To use the rsync and copy this entire command, including this Docker Compose. You can also even write the script. Or what you can do, there are two ways. I'm giving you scope. There are two ways. After this build is successful, after it has copied the GitHub SHA into the Docker Compose. When you SSH into the server, you can install Docker on your script. You can do it like that, or you manually go into your server here. And install Docker by yourself. Just install the Docker inside here. So when the GitHub pipeline enters into the server, it will just copy this code, run Docker Compose and Docker Compose up and all those things. Within the pipeline, all the steps should run. This whole step I just narrated, from checkout code, setting up Docker, login to Docker, build and push, update Docker Compose YAML, SSH into server, copy code files, copying Docker, copy it, then start Docker Compose. The whole thing should be in one YAML. Same thing with this. I prefer you do backend first for doing front end because the backend has to be active before the front end. So you do your backend first. Once the backend has started Docker Compose, you do the front end and database, and everything should work perfectly. I want a final result where I'll see the IP address of your server, and I'll see my dream location app showing, working with database, everything. So yeah, I've given you one part of the scope. You just have to go and continue it. So I've given you the scope of your next task, your assignment. If I were you, I'll use this weekend to practice, find the commands that you use to get this done. So that when the task drop, you execute. For those of you that did not do 4 and 5, this is the best way to catch your people. This is the very perfect way to catch. A lot of people dropped. A lot of people, I got only 13. I don't know why people are giving up at this point, but inshallah. So yeah, that's just it. I have some repos, Sha. I can drop them for probably after the class. I will drop my own repo because I've done the project before. But I won't want to drop my own repo though. But Sha, I'll drop it for guidance. So yeah, that's just it basically from setting up a VPC. So yeah, we have our complete VPC here. The next after this one, the next project we will do is setting up a VPC from scratch with auto scaling and load balancing. So you understand all the auto scaling and load balancing and what it does basically. So yeah, any question? Any question of the day?
So I have a question.
All right. Sorry, who's asking? Please, I can't see my screen.
Yeah, this is Ayus.
Okay, Ayush, well done.
Good evening, sir.
Good evening.
Yeah, you as it regards and do the GitHub share that you said we'll go and update the what do you call the Docker Compose.
Yeah.
So that Docker Compose image that we use there is for the first project.
Okay.
The image is different.
You update the image, man.
Okay, we'll update the image.
You update the
Oh,
image with the so you can create now when you are building the push, the build and push. If you can build it to a new image, you understand? You can build it to a new image, or you can build it to a current image. Then you go to your Docker Compose and update the image name.
okay.
Understand?
Yeah.
Update the image name to the
Okay.
new image. Then with the GitHub share. So once the whole build runs, it just only updates the right part, which is the version, which is that GitHub SAH commit ID to update it. Then it will now copy the whole code to you. So it will do that whole. Now one thing with rsync. So rsync is what transfers your code from GitHub to the server. One thing with that rsync only transfers the change. It does not transfer the full thing. So for every time the pipeline runs, it's only the GitHub shard that will be changing on your server because that's the only change. You understand? It's only the
Yeah.
GitHub SE that will be changing on your server. So once it changes, to run the Docker Compose up again like that, basically.
Okay.
Bash, you raise the hand.
Thank you so much.
Well done. I can hear you. You're not saying anything. Can anyone hear me? I can't hear you or your
Can
network.
you hear me now? Is it
Yeah,
better?
I can hear you now. I was not hearing you before.
Okay. So I wanted to ask, I don't know whether I should ask in class. I used to have an AWS account last year. So I
Mm-hmm.
don't know how I'm going to create another one because I'm having issues
You
with
don't need to
mine.
create another one. You don't have the password again. You can do forgot password now.
No, they were telling me something about I think after a year or something, it's not like you don't have like free credits again.
You don't have free credit after a year now. After you don't have free credit, so
Yes.
whatever you pay for it.
No, that's what I'm saying. So I didn't create anything then. I think I'm sure of that. But the
Uh,
thing is now that how do I get a new? account, and can I use like someone's
You can use
account,
yeah,
like
you
an
can use someone's
instance?
account. You can use
I just
someone's
want,
account.
and is it a must that it must be that we are using AWS? That's a must, abi? Or if you have like access to another cloud service. I don't know if you got me. Hello.
I believe you probably had network issues.
The network.
But
Can
Bash, you can go and create another email address which you are going to use to create another AWS account.
Okay, I'll do that. I just
And
wanted to.
just
Thank
create a new email address, then use that to create a new AWS account, so you have another free tier again.
you. All right, no problem.
Yeah. Okay. All right. Good evening, everybody. I just wanted to speak about this AWS accounts and how we can get free credit. You know, probably if we have done it, maybe the time I posted the link on how to get it done, probably by now, or maybe the next 1 week or so, AWS will give you $300 free credit that you can use for the next 6 months. At least if you are building any resources and mistakenly you go and build something that the free tier does not cover, you can be rest assured that they will not slam you a bill that you will just be shaking on how to pay. So I'm going to share a link after this class, maybe on the Discord channel, on how to, create an AWS account. And after that, you can go and apply for the $200 on their AWS community. You also create an AWS community account as well. I will send a link and you just read through the, what's it called? It's a post that I wrote on LinkedIn. So you can go there, read how to, step by step on how to go about it, and you get it done. So that will save us a lot of, headache.
I'm so sorry. I don't know, my internet just went off. So I'm here. Does anyone still have any question? I'm sharing my screen. Someone was saying something before I came in.
Yeah, I was the one speaking. I use.
Okay, yeah, what were you asking? Sorry.
No, it wasn't the question. I was just like, anybody that really have issues on creating AWS accounts and how to get also a free credit as well.
Yeah. I think you
Uh,
dropped the resource on the group now. I saw it.
yes, I dropped it. So I was
Mhm.
just encouraging people to go ahead and get it done so that they can.
Which one is what email do we use? Use your normal email now. Gmail.com, yahoo.com, anyone.
No, I think the requirement was a business email. So I don't know if the Gmail would work.
Oh, for the free credits.
Yeah, that's why I saw there the 300.
Oh, okay.
Yeah, for the free credits, you
So none of
can.
us have a business email tied to our AWS account. Normal Gmail.
Okay.
Well, I don't know if I should answer that question. Me, I don't know, but majorly they require a business email for the community that you are going to
Okay.
use to apply for the $300. For me, I have a personal website. So from that website, I create an email like like www dot my name dot maybe info dot
Yeah.
my domain name, something like that. So
Mm.
that looks like that is a business or corporate email address, unlike the one Yahoo will just give.
Yeah.
So I did that and I got it. So I don't know, maybe if you use your ordinary Yahoo, whether it will work. They might reject it, but I don't know. That is what I used, or that is what was stipulated on the requirements.
Hmm. No problem. Oh. So, yeah, any more question concerning this VPC, everything?
Hello, good evening.
Good evening. This who is speaking?
It's Wilfred.
Oh, Wilfred. Good evening.
Good evening. Sorry about the noise. I'm not home yet. I'm still on the road.
Yeah, it's fine. It's fine.
Okay. It's about the tax.
Okay.
The for the DB, are we using an image
Yes.
or
It's a,
RODS?
no, don't use RDS. So it's an image. Oh.
Okay, all right.
So you are pushing as you're copying the Docker file, you copy the Docker compose to the server now and do the
Okay,
Docker compose up on the server instead of on
okay,
your laptop that you did the last time.
okay,
Understand?
okay,
So
all
you're
right,
not using RDS, so
all right.
RDS is expensive. Oh.
Just wanted to be clear.
No wala. So yeah. Any more? Please, if you have not done tax 5, finish tax 5 because tax 5 that will usher you to tax 6. I think this trilogy of taxes is what helps me. What I think dropped a lot of people. Especially people that used to copy assignment a lot because people that did not copy, people that went to go and copy tax 4, by the time they finished, oh, tax 5, oh, kini, it now dropped people a lot. So please just try your best and submit on time. Not just on time though, submit something accurate, basically. So since there's no question, I'm looking forward to when the tax will drop. I'll just use this weekend and document it so that when they give us go ahead, we'll drop it. And anyone, whether late or early, submission or submission. Basically. So yeah. So that being said, thank you very much for today's class. Let me stop recording. Oh, who, oh boy, wait. So who's the new Ayus, please can you stop recording? I think as I left, it made you the host. So just stop recording.